And our last conic is the parabola. So the parabola comes from when we slice the cone at a single angle, not going through both parts of the cone. We get a parabola. We've dealt with parabolas all year long. We've seen many different ways in which to write the equation of a parabola. Today we're going to be specifically talking about the conic version of a parabola. So what does that mean? What is the conic version of a parabola? Well, it says that a parabola is a set of all points in a plane such that each point in the set is equidistant from a line called the directrix. So here is the directrix for this parabola. And a fixed point called the focus. So here is the focus. So every point on the parabola has the same distance from the focus that it is from the directrix. That's what this is saying. Where do we see parabolas? Well, we see them in bridges, in architecture. Also a main application or a major application is satellite dishes, as well as headlights and flashlights. So another feature of a parabola is that anything that hits the dish, or the curve, I guess in this case satellite dish, is going to reflect towards the focus. And the opposite is true also. Anything that comes from the focus is going to shoot straight out from the dish. So that's why if you have a satellite on your roof, or satellite television, DirecTV, or something along those lines, that node that you see in front of the actual dish is at the focus of the parabola, and the dish is parabolic in shape. Same is true with, like I said, headlights and flashlights of a car. Maybe not LED lights, but still the casing that they're in is parabolic, so that the bulb is actually at the focus and all of the light projects forward as it reflects off of the parabolic encasing. Okay, so with parabolas, we have a vertex at the point HK. A parabola does not have a center. We are also going to have a distance P. P is the distance from the vertex to the focus and the distance from the vertex to the directrix, because those are the same by the definition of a parabola. We also have two different ways in which we can write the equation of a parabola. When we're talking about a function, which is all we've dealt with so far this year, we would write it in the form of x minus h quantity squared equals 4p times y minus k. But when we're talking about parabolas in terms of conics, they do not have to be functions. So the y term could be squared instead of the x term. And then we write it as y minus k quantity squared equals 4p times x minus h. Notice that h is always with the x and k is always with the y. K with y, h with the x. All right. So let's look at an example. We're actually going to do the horizontal axis example together, because this is a little bit different than the vertical axis, which is something that we've done before. If you can do this, you'll be able to do the vertical axis, hopefully. So, vertex, we can just pull that straight from the equation. I see I have x plus 7, so the h value is negative 7, and I have y minus 1, so the k value is positive 1. What is the p value? Well, I know 4p equals 12, so p equals 3. How does that help me? Well, I know that the focus is going to be in the direction of the opening of the parabola. So let's actually draw the parabola before we find the rest of the stuff. So the vertex is at the point negative 7, 1. So I'm going to go left 7, up 1. Alright, so if this is a horizontal axis parabola, that means that it opens either to the left or to the right. So this is not a hyperbola where it's both, it's either or. How do I know which one it's going to be? If p is positive, it opens to the right. If p is negative, it opens to the left. For vertical axis, it's going to be up or down. And again, this is p is positive, p is negative. So this is the parabola that we're used to. This is the only thing that's new, but it's still pretty much the same as the old parabola, it's just on its side. So p is a positive 3, therefore this is going to open to the right, so I'm going to just draw a parabola going to the right. But now I'm going to start graphing some of the other features, which is going to help me find them. So if p is 3, that means that the focus is 3 to the right of the vertex, because the focus is inside of the parabola. So the focus is at the point -4, 1. And the directrix is going to be 3 to the left. But the directrix is a line, so I'm just going to draw a vertical line here. And that was at x equals -10 because we write the equation of a vertical line. Axis of symmetry is the line that goes through the vertex and the focus. So my axis of symmetry is the line y equals 1. So if we have a parabola in standard form, there's much less work to graph it and find the information than we had for the ellipse and the hyperbola. One thing to point out, the directrix and the axis of symmetry, those are better drawn as dashed lines. However, again, because of the limitations of this computer, I am drawing solid lines. I apologize. Okay, so I want you to try and do this one on your own. This should be a vertical axis parabola, but you will find everything the same that we did here on the horizontal axis. Pause the video, do that, unpause when you're ready to check. Okay, so I can see right away that the vertex is at the point -3, -5. 4p is 8, so p is 2. So then I can go, and since p is positive, and the x was squared, I know this is going to open up. So I can draw that. The focus then is going to be a distance of 2 up from the vertex. So that is at the point -3, 3. The directrix is going to be a distance 2 down from the vertex. So that is going to be the line y equals -7. And then the axis of symmetry goes through the vertex and the focus. So that is the line x equals -3. Notice that the axis of symmetry is an x equals when this is a vertical parabola, and it is a y equals when it's a horizontal parabola, and the directrix, those switch as well. So when it's a vertical parabola, the directrix is a line y equals, and when it's a horizontal parabola, the directrix is line x equals. Now, what about the generic form, or the general second degree equation? How do I identify a parabola? Actually, a parabola is the easiest one to identify. Either A or B is 0, meaning only one squared term. So with a circle, an ellipse, and a hyperbola, you're going to have an x squared and a y squared. Where a parabola, you're going to have either an x squared or a y squared, not both. So if we look here, oh, look, I have just a y squared. Therefore, I know this is a parabola. So, what do? Well, the first thing I want to do is I want to identify this was a y squared. So that tells me right away this is going to be a horizontal axis. So I'm trying to get this to look like this equation. So I'm going to isolate the y terms. If this was a x squared, I would isolate the x terms. So we will do -y squared minus 2y equals -4x plus 33. Now we are going to complete the square, but only with the y terms, because they are the only ones with a square. So first we have to divide by a -1, since that is the leading coefficient on the y squared. So rewrite this as y squared plus 2y, leave a little bit of space, equals 4x minus 33. Complete the square. Half of 2 is 1. 1 squared is 1. Rewrite this, factor y, that's a plus, so plus half of 2 is 1. Quantity squared equals 4x minus 32. Now we're really close to having this in standard form. What else do we have to do is we need to get the coefficient on the x to be a 1. So we don't divide by 4, we factor it out. So we'll get y plus 1 squared equals 4 times x minus 8. Parabolas are also the easiest to get into standard form because you only have one term you have to complete the square with. Identify our key features. I know that I have a vertex. Remember, we don't have a center. At the point 8, negative 1. I know 4p is 4, so p is 1. So, since p is positive, and this is opening to the right, since it's a y squared, I know that my focus is going to be added to the x value of the vertex. So this is going to be 9, negative 1, and the directrix will be subtracted from the x value, and so that will be at x equals 7. The axis of symmetry then will be the line y equals negative 1 because it goes through the focus and the vertex. Alright, I want you to try this one on your own. Identify the conic, write it in standard form, identify the key components. Pause the video. Unpause when you're ready to check your work. Okay, so we should recognize that we have an x squared, therefore this is a parabola because there's no y squared term. Also notice there are no other x terms, so this one should be much easier. We don't actually have to complete the square with anything, because taking half of 0 and squaring it is still 0. Alright, so we isolate the x's, bring everything else over the other side, get it into our standard form. So our standard form is going to be x squared equals 20 times the quantity y plus 3. So my vertex is 0, negative 3. 20 is 4p, so p is 5. Since this is an x squared and p is positive, this is going to open up. So the p value is going to be added and subtracted to the y value of the vertex. So negative 3 plus 5 is 2. So my focus is at the point 0, 2. And negative 3 minus 5 is negative 8. So the directrix is the line y equals negative 8. The axis of symmetry then will be the line x equals 0 because it goes through the focus and the directrix. Okay, so again, we have dealt with parabolas a lot before. We haven't looked at the focus and the directrix of them. We have looked at the vertex. We have also looked at the intercepts and the solutions. Right now we're just focusing on the vertex and the focus and the directrix. The key thing to look for in a parabola is that only one term is squared. So you're only going to have to complete the square potentially with one of the terms and isolate everything else.